fundamental
Yeah.
to get.
Yeah. Example, if you would like to take an interview to get a job, you can just chat with human resources on this one. You do not need to take it now. Okay, so I will introduce I will take some web data conversion. So they are not interested in this. Okay.
I think if we going for an interview with our future, like for electrical department, so they will ask maybe at least 3 questions for this.
Questions, actually questions, or you mean the handwriting exams is one part of the interview, or is only a small part decide whether you can get the job or not. However, human sources or your potential bosses is a human, right? You have to make him happy, So in that case, so you are score of your handwriting exams, but you only take smaller roles, then you'll be right. Okay, so I think this new trend is very important for you.
It's not only important for about this graduation, is very important for our life.
No, I mean, so because the industrial or the academic field is interested in this, so everybody were interested in something new, right? Everybody were do not match the calculations, so it will be much useful for your interview, I think. So okay, so what is a smart grid? Let's say that the grid is a transmission network or the power network or system work of our previous lectures. Also, you see the smart is very clever, never our systems. So the one major point of the smart grid is to the information and communication technologies, how ST technologies in the grid. So there will be much more data and more communications in this operation or in the control of the grid. The second one is the smart grid focuses on the distribution systems. So that's why we will just take many researchers have spent a lot of time on the microgrid. So as I introduced in the first class, so the microgrid you control or you have to manage a small group or small area of the systems to be much easier. So if you have a very good or very mature knowledge to master or to manage a small group or just like a distribution systems, then you may have the ability to handle the large scale of the systems. So that's why the smart grid focuses on the distribution systems. Also, another reason for this is that the distributed systems refers to the systems with a voltage level less than 100 kilovolt. So just like our campus, right? So the system will be much more complex, you understand? So if we are in UHV or high HV, do you remember that the high HV networks in China? We can just to figure out or just to describe that in only one figures. It's very easy, right? The control and manage of this high voltage network is very easy because its structure is much more easier. However, the distribution networks is very difficult. So after you have learned about the power flows, you will find that the power flows in the distribution network is very or difficult to solve. Or in some worst cases, you cannot even get clear how this power flow is working. So we would like to take our explanation grid. So the grid includes its set or the set for the transmission and generation is also includes the end use of the electricity. Let's do this. It's the bar generations, right? And this yellow triangular is the distribution substations. Maybe it is 2 and 20 or 1 and 10 to 35. So then 35 kilovolt will be transferred to our campus. So end use is for it's actually the nodes or the consumers here, right? This for just to send power to distributed generations. It will be for the conserve or for the backup power. Backup power indicates that some of these power transmission or the generation will be out of use. So this conserve powers can just aid and provide some powers to the consumers. So the understanding applications of the ICT, so actually the information and communications includes one of the most important systems, the survey, control, and data acquisition systems, SCADA. So this SCADA system, this system is quite important in some of the risk areas. If you read some papers, you may find maybe 10 or 2, or maybe 1 or 2 in 10 papers will have to study about this. It's very important because this system will provide the telemetry of the generation, transmission, data, and control. It's actually so it's providing and receiving data. It will connect data from a different aspect, no matter in the operating, no matter in the consuming, or the generation. Every step or every part of the transmission networks, the data from it will be connected by the systems. So the methods used in this system is quite important in smart grid. So another one is the energy management systems. So it's actually one assumption is that our top systems will not just focus on the electricity anymore, and we will just to connect with other energies. So just like the heat, right? The heat, the water, or the every energies, or just like the petrol, the energies, different kind of energies except for the electricity, we just to get together and to impart the energy transmission network, not just the power transmission network. Energy includes power and other kinds of energies, right? So that's why we need the energy management systems, including the independent system operators. So the system operators is the man who charge for this management or arrangement. So these two, the EMS and SCADA, if you would prefer to continue your academic life, or you would like to be the professor in the universities, then you have to and writing some papers, right?
We have to in the next year. That time we have to write a paper,
right? But if you would prefer to use some journal papers, that you read the paper, you submit to the journal, and it will be published in the journal, you will find. Then the first step is to read and make papers and you will find, wow, it's a very hot topic, EMS, and then this CAD systems, so it will be hot topics. Some additions to these transmission systems. So one of the most important devices or the equipment is the phasor measurement unit, or we call it the PMU. PMU is now actually the most frequently used to connect data. You see in our previous lectures, so in the system, so the voltage, the current voltage, current or the voltage in the transmission lines. So we know that it will be okay, the 1 volt should be 0 degrees, right? But how this voltage comes from this? So and just like some base data, so like the voltage, well, the amplitude of the voltage or current, the phasor of the voltage and current. So the PMU is the base of some data mining or the SCADA systems. So it connects data, okay? So the second one is the telemetry of temperature and the measurements of the transmission lines. Temperature, why temperature is important? It's in the last page of our previous lectures, right? When the power transfer is beyond or exceed the constraint of the transmission lines, right? You can see that if we convert the 129% of the powers, the transmission line we're using expressed in the right color. So the heat of these power losses will definitely damage the transmission systems. So that's why the temperature is very important. So as I told you that in some cases you can just transfer a little bit more powers in the transmission lines that is beyond its constraints. So maybe 5% or 10%. But how to decide why is 5, why is 6, why is 8% temperature? So this be another major topic of our field is overwhelm power in transmission systems. These researchers are focusing on just to decide how much power that a transmission line can just to tolerate. Maybe 105%, would be 108 or 110% of power. So many of them are based on the temperatures. So when the temperatures of the transmission line is acceptable, so you can just add more powers. But when it's very hot and it's almost just to be put down, so touch. So the temperature, the light temperature is very important. It's important as some other measurements
of transmission line.
So one of the reasons for this is that the temperature is easier to measure. Just like this, you have the measure gun, the temperature measure gun. If you going out of the campus and when you going back, you will be say stop. Hey, stop.
Like this,
Just like down the temperature measure. It's to measure your temperature of your body, right?
Like something. Now this technology use something like materials.
Yeah, materials.
When this is stored and they put something for hot, this is going to connection.
Yeah.
So when this is going to like 150 degrees over, more than 150 degrees over, this is going the cross connection.
Yeah, it's actually so the varying of temperatures will be classified in two types. The first one that I use that is the fixed devices will be just be distributed in some important nodes. Like if you in the center of the transmission network, right? So you will have to need some fixed devices to supervise this or just to measure the temperature the whole time. But in that case, your devices are very expensive. We cannot just to place all these devices in all of our networks. So that's why there should be some staffs in our utilities in my country just to perform the inspection. That they were the car or just the drone in the sky to say, okay, so these long distance transmission lines one time from from Changsha to another cities.
Slowly.
Right? Yeah. Just like in Chinese we call it 巡视检查, just like they are moving and inspect, not the face devices. So your devices is good, but it's very expensive. We cannot afford the thing for so long.
For this one, we have to use a special meter. Like this will be going to be more than 150 degrees Celsius. They will disconnect automatically and save our device.
Yes, you're right. So it's actually because this temperature, because the OLED power in transmit now is really hot topic. So if you would like to do something
like this device, when I playing game or something, this have a two cooler fan downstairs, and when you think he is more hot, he just lets down his graphics. Because when you play using this graphics, it will be hot, very hot.
When your temperature your laptop is too high, it will just to cut down your CPU performance to be sure that the temperature is in the safe range.
Yes. If you use this set, if you use this one to kill and this one, this will be escape. You have to use this micro.
Okay. So I will bring you your micro next time. Okay.
Because this make escape of your screen.
We can get one screen on this screen, one less screen protectors.
Yes.
Okay. Thank you for your reminding. Okay. Okay, so let's see, smart grid, some customer tips. Okay, so in our nature, so we're going to learn something about the smart grid, so healing grid, the micro grid, or the digital grid. Okay, so there are different kinds of grid, but also all of them are called the smart grid. It focused on the different aspects, just like it's separating, it's doing something wrong in one part or in one devices. So this grid can be just to handle it itself. So okay, so this topic is our views. Maybe we do not have sufficient time for all of these topics. Ever choose some important, okay? So maybe we have the best idea about this. And you can see that in our smart grid, what we have learned or what we have to know is not just about the knowledge in the power systems, right? Architecture, the energy, the human factors, or ecosystems, right? The storage, the retail. So okay, so as in maybe one, I will take one nature and I will introduce some power systems of the power market. Power market in the United States, as in is very neutral market, and so that our country, I guess, it will be learn something from this power market. Okay, so the solar, the electrical vehicles, right, the very top topic. Okay. So I will give you the first, the wholesale. So I will give you the base introduction about the wholesale of the smart grid, but this lecture I will just do based on the smart grid in the United States, or especially in Texas. Because I have studied there and I think
Texas University.
AM University, yeah, it's located in Texas. And so we have learned something based on the ERCOT. Like ERCOT is the utility of the Texas overview of the ERCOT. So, okay, I'll show you the interconnections. So, we have 9 interconnections in China, right? And our first lectures by days, you can see, for example, 1, 2, 3, 4, and 5 in Alaska, right? And beyond the map. So that's why you can see that the Texas is just here, okay? So the Houston, everybody knows the sport, NBA,
Yes.
the luggage, the Spurs, the Dallas, what is the,
I don't know that.
okay, so we have to fly from Beijing to Houston and with the small village police station here, my university. I get a master degrees. Okay, so anyway, so that the Texas is the wide interconnections. So that's why I will choose the Texas, the agriculture in Texas to be examples, because it's not only my master university is already there, but it is also one interconnection, so it will be much more representative for any other states, just like here, so right.
I went, when I went from Tanzania to Lodi, I saw something, some winter wine, big winter wine.
Winter wine?
Winter wine, they up of the hill. the
Winter,
out of,
winter bean, right. In our in Changsha, actually winter bean,
out of the city.
most of the winter bean is used for the education or research. Because we know, so in our central areas, the wind energy is not as high as most western countries.
Because this wind speed is not high.
So maybe, so as you can see, our outdoor, yeah, there is the wind turbine. It's very small. No, yeah, it's just like the first building of the engineering. When you're building the first floor as a building, you can see that the floor,
So the
at the top of the floor, you can see that there will be 5 wind turbine will also. Although it's quite small, but it's still the wind turbine.
I saw this real wind turbine is big one.
Big one, right?
From Tanzania, this city, from 71 kilometers from here.
Okay, so maybe in the area, so it will be the very vast plan, so it will be.
I went there for with my Chinese friend. This is for research, but this is very big.
Yeah. But if you have the tree in the northwest, because last night is July, I went to Gansu. You know Gansu? Yeah, it's a very northwest country. Gansu, yeah, it's really far more wind turbines because the wind energy and solar farms be much more frequently or used there. They have more potentials there. Right?
Nowadays, the scientists put a wind turbine in. Like not wind turbine, this water turbine. But this look like a wind turbine, a small size, underwater.
Underwater?
Yeah, this rotates 360 degrees.
Like this?
Yeah, this is a turbine, and this can.
It's the horizontal,
yeah,
horizontal, right?
And this can.
Horizontal.
It
Okay.
is small, a lot of under the sea.
Oh, you mean that this is a quite small.
Yes, very small.
It's very small. So it's not frequently used because it is used in the. It should be the Thai farm, head farm. Head farm is used located in the coastal cities, right? Because the sea, the tides, the energy of the tide to generate some power, but it's has a very strict requirement for the location, so it's not quite common things seen in other countries. So
And another thing is using the wave, sea.
yeah, we will see, right? However, so
There is a hydraulic and there is a circle with the wave. When the wave comes, this is going there.
Yeah.
This is make a pressure of liquid and generator is running. And when this is going down, this liquid is coming, the generator is running.
Okay, so about the assembly demand, shortcomings of this type plant is that the power being generated is cosmic.
It's quite small.
Right. So the arcade, right? The arcade is the electrical reliability council, the Texas, right? So it will actually be active there. So it's actually the utility, the arcade is performed as a stage grid in our province. So it controls everything in Texas, right? View, so we can say that has been taking or 9% of the load in Texas, right? So exactly for these areas. So in the rural ranch, it compacted consumers. So compacting choice consumers means that the free market, the consumers in the free market, so that you will prefer to decide which utility company, which utility company that you pay for the electricity. Okay. So there will be why we call it the compacted. And in here, you can just to pay your money for the state grid, no other choices. Right? Okay, so this is energy source distribution of Texas, right? Generation, the energy use. So you can see in China they will use the coal as energy source most frequently, or of course 70 or 50%. But in the Texas they use the natural gas. Will be more than the coal. Coal is only 17% and even lower than the wind. Some you can see some advanced meters or the response resources is quite different from the resources response and meters in our traditional power system. So if we have time, if I have free time, I will try to do some lectures about this too. Okay, so it depends. Okay, so the first thing is the communications. So let's see. So the acronyms for the market participant type test. For the first one is the qualified staggering entities, and the other second one is transmission service providers. Staggering entities, what is this? Okay, so I will show you in the next speakers. Resource entity, that is the generation. TSP, so I think to be the transmission service provider, and DSP is distribution, right? So this is the high voltage and low voltage. So you can say in Texas, the transmission and the generations is different, as divided or separated. So in China, the generation entities is also not controlled or not managed by state grid. However, the difference between my country and the Americans, so is that they have more options for transmissions. Like our monitors, today has a wind farm, right? This wind turbines you said we assume that it's yours, okay? So you have 3 wind turbines, generate some wind powers, and then in China you can just sell it to the state grid, right? Because the state grid transfer this energy to our campus, and then we use it. However, if you are in the Texas, you can choose the company A, the company B, and company C. Okay, so how much you would actually pay for the energy, right? You have the choices.
Like I can choose wind turbine, coal, gas, water turbine.
Yes,
That's my choice.
yes, of course. Generations there is in the free market, right? And
But sir, I think for this year's curriculum is easy for this customer, but government waste a lot of money. This is my area, sir. So this is wind turbine, wind turbine, water turbine. This is coal, and this is gas.
yeah. What?
For this transmission line, they have to. This is generation, generation. This transmission, transmission. And
Yeah.
then distribution, distribution, and this is the customer.
No. These energy sources should be sent to the entities. All of them should be converted to electricity, right? You cannot just do try to have a track of the course and send to your doors. Okay, so please use this course to turn on our air conditioners, right? Course cannot be added to this. You should just send that to the entities, right? Entities, and then entities just to generate the powers. The powers then sent to the transmission service providers, right? So that's why this.
No, I mean, sir, I have 4 companies. This 1, 2, 3, 4. So I can choose one.
Of course, if you have the generation, you have these 4 generations belong to you. You can choose which one you use to generate the power, and then the power you need to sell it to one of the transmission service provider, right? Because you need to transfer your power to another consumers, right? So that's why I say that the difference is that you can choose. You have more than one options, because in China you can just sell it to the state grid, right?
China has no option to choose.
Transmission. This part in my country is actually monopoly currently. So the state grid or in the
Or
southern
line.
line.
When you go outside of city, like BBQ market, after this car showroom, after when you go out this city, you can see a lot of this tower of transmission.
And all of the towers in China belong to state grid.
State grid.
State grid. Yeah, it's the only companies in my country. Okay, so this aircraft is in the breeze. It's why we see the maneuver of them is higher, right? Okay, so these 2 parts will play an important role in the communications. Okay. So you can see that this is sent to the powers, and this is what we call the generation, transmission, and nodes or consumers, right? This is the power analysis, what we learned in the power system analysis. But in the aircraft, this part you can see the power masters, the LSE. LSE is the 45 scheduling entities, and the QSE is the QSE is the qualified scheduling entity, and the LSE is the node serving entities. So this one is connect from the generation and the consumers to decide the wholesale market settlement. Settlement is the price for the electricity. That's like you sell your generated power to the transmission line, or you need to pay for the electricity. What you need to pay for, how much you need to pay for electricity, right? So they connect information or data to solve or to see wholesale settlement. Settlement is the price, right? Is the price paid or price to make a deal, right? And operations, the data is charged is controlled by the aircraft, right? Operation aircraft control the transmission, right? And this is maybe the supervision, or some department government that to supervise and to control the aircraft that we report. Okay, so they will say that everything doing well for you, right? So it's the government. And this is why the communication, this is how the communications in this smart grid in Texas is working. QSE, okay, so they were saying more about QSE codified scheduling entities, right? So each participate the market and in the day ahead and real-time market. So here you have the brief introduction of this day ahead market is that everything is scheduled. Just like our monitors have 100 megawatt power and heat that is selling to the transmission service, transmission network, right? So you have to sell it in the day ahead market because your power will be sent for in the tomorrow. But however, you have to decide the price today. So why we call it the day ahead? In day ahead market, almost everything is scheduled. But if something wrong or some coincidence or emergencies appears in the real-time market. For example, so our monitors manage, he has get the money for the 100 megawatt. However, at the night of the day, he finds that okay, so maybe one of your generators is out of work. It does not want water anymore. So
okay, I have only 50 megawatts.
Yeah, you have only 50, but you have received the money, right? So it's your responsibility to
sell this power.
No, you can send the remaining 50 megawatt to the transmission network, and you have to buy another 50 in the real market, in the real-time market. So
make it this one.
Okay, so in most cases, the real-time markets, you can imagine that the price will be higher. So maybe you will lose sometimes at this deal. So that's that's why the the real-time market and the market is doing.
I think that to make money easier to generation power and stuff like this one. I think it is easier to make money.
But in a lot of cases, right, if you have 100 megawatt in the schedule, right, you receive the money for the 100 megawatt, but actually your generators can generate 120 megawatt, right? Okay, so in the tomorrow's real-time market, maybe another his generators, maybe your generators are also aware because his generators, one of his generators were out of work, so you can sell your 20 to him, gigawatt to him, and at a very high price. Because if you cannot send the power you sell to you receive money, right? If you do not send the dear power to the transmission network, there will be a violation fee and the fines will be much more expensive, even compared with prices in the real-time market. So you need to handle it by yourself, not by others, right? Okay, so the three primary modes of communications with the participants, right? So the first one is the inter-control centers. Inter-control center communication protocol. So this is very important protocol, but I'm not familiar with this because this is not the main or not a key point in our power system analysis. So it will be signal process, signal analysis, if you have taken that class, you will learn something about this communication protocol. So the second one is market information system. So MIS is just like what these two are doing. The market information generation, consumer, right? To decide the market, based on the market or what, and the archive is chosen for the translation. And the third one is property communication, okay? And in some cases, if you need some emergencies, so you can also use the verbal communications, right? Rather than this protocol, because in the because in emergencies, just do not use these very complex expressions in computers like words. Hey, send me 20, I need another 50 megawatt and take my money. Right? Yes.
It will make him more benefit.
Yeah, of course. So make sure that you maintain and inspect your generator as well, and inspect that these generators will just give some opportunity breaking down, and you get more profit. So the archive is actually, so for the transmission part, right, the archive is using this SCP, that the protocol, right? Protocol is this market information system operators, yeah, right? This for transmission, for generation, and consume, for market and generation. Okay. So it's actually, so we can say that the data point, the very big volume of the data point, right? The point between the two and hundreds of the resources and the QSEs, right? So for the QSE and archive, for one source is represented by the 36 points of data points, right? So we can share the data and reach very soon, right? 2 to 10 seconds, it's very quick. So it's the package, right? Do the package. Package is a pack. You can do the pack of the data. And you learn something about the computer science, right? So okay, so if you do not know about the package, just like that, we have to pack different kinds of the data into the order, into the screens, to make sure that all the data can be readable and easily accessible. So we call it a package. Right? Okay, so the data elements. Okay, so what is included in our in that data? So the first thing, the first fact that is logic-based on flash. Okay, so just like how much our monitors manage would like to generate in tomorrow. Okay, so the part is that generation level. Okay,
Individual resource.
yeah, you need to send, or they will connect your data.
For 5 minutes.
Right? At 5 minutes intervals for every 5 minutes, right? Because your generation might be changed, your plan for generation might be changed very soon. So another based on resource specific logics. So they were just to connect the data by different resources, right? For the core, yeah, it's going to be one component. For the solar energy, for the wind, there will be different people, different stars for different current sources, right? The second one is reserve development. Reserve is backup energy. So if for your generators, you have 50 megawatt power as a reserve, right? So that's why I say if you can generate 120 megawatt and you just receive the money for 100 megawatt, right? Then the 20 megawatt, we call it the reserve. Reserve is also important even in China because there will be one field, study field, risk field to calculate how much the reserve you need, right? Yeah, if you have 20, you can just to make sure that when there is an emergency in your generations or just to sell your reserve to him. This is called reserve deployment. The second main point price settlement is called the charging price, actually. So it's just you sell to the transmission network and you pay for the utility to purchase the power. But this is the settlement. Settlement is actually, in most cases, is decided in the day-ahead market. So the fourth one is the power flows. So it seems our conditional analysis is also important here. The power flows, right? The last one is the resource equipment conditions. Okay, so make sure everything working good, right? Make sure that all of your generators are working in good conditions. Make sure that your 20 megawatt reserves can sell a higher price to him. If he do not pay attention to the maintenance inspection of his generation, right? Okay, so there will be 5 aspects of data that will be received by the shortcut, or whether it is too much QSE and LSE. So there will be battery between these two, so there will be has a very significant impact of the all systems. Okay, so this two is in charge of the power market, right? Okay, so here's some things. So the SCP, the protocol communications is achieved by the area network, right? Where the area network is actually not wellness, I think it's in well version. The currently in well versions. So the second point is that the participant, right, was in which to facilitate for the connections, so has a member responsibility, right, for to make sure that this protection requirement to make sure be achieved or be satisfied, right? So you can see the architect is responsible for the installing and maintaining. Actually, I think he only focus on the transmission network, but for the generation and the consumers. Generation is in you and your charge, right? It's all your own companies. Okay, so then the cost is also the trade-off between this effective or the responsibility and the cost. That is very hard choice for them, basically, sometimes. Okay, so I will give some details for some part, right? The market terms, so the UI-based interface, right? So because it's also in the network, it's based on the network of the energy transformation, right? So the second one is communication into the public and the market participants. So the MS is just focused on these two parts, right? And just to use as a group or individual. So what the MIS can provide include the 5 aspects, right? The dashboard on the preconditions, the market, the forward, which means the time we're coming soon, that means the market result in the future, the planning model of the transport condition, the settlement, and the reward user guide for the participants, right? So here is one example for the market information, right? So this is, you can see the value had market result. You can see just like the price directions. LT is means the occasional marginal price. You can see it's actually in their network different of same amount of power in the different nodes in the different price. I will take the gasoline price as example. Do you have the car in Changsha? No matter where you are, if you go to the saddle pack, okay, it used to be in the same corporation, like if you go to the saddle pack or China Petrol to just to refill your oil tank, right? If you are in the saddle pack here, or if you are in the saddle pack in another cities, even in another cities, you pay the same price. Okay, so unless you are go to the Tibet or the Xinjiang, it's very far distance, there will be a little bit higher price, right? So the electricity price is also same. You are in your campus, you pay the residential price, right? Is 0.69, right?
654. But I use 0.65 per unit.
Okay. Anyway, so it's also. But if you are living in another maybe 10 kilograms in the north cities, you are also pay the same price. So, but in their networks, the electricities in different places are different. Just like their petrol companies, if you refill your oil tanks here and you refill your tank oil in the train station, you pay the different price. Also, the electricity is also same. So maybe the campus is in the suburb, right? So we pay, or say the electricity here is cheaper than the downtown of the city. Okay, so our EMPs, right? So the clearing price capacities, the many kinds of the data. Okay, so this is the QSE forecast, right? To forecast how much. So, okay, so here is also the hot topics, the load forecast. Especially in the solar and wind energy, you have the wind turbine, right? You have 3 wind turbines. When you have to forecast how much power you may or you could generate in tomorrow. Because you have to decide the price or decide the amount you sell to the grid, right? Wow. Okay, so I'm just finish this page, okay? So the support information, right? The ancillary service plans, ancillary. If we have time, there will be a lecture to introduce the ancillary service. I think it's also important. Okay, so in this page, we're finished here. You can see that communications, right? The large motion actuation. 0, so that starts the beginning of the day, say 3, we're into 24. 24 is here, right? The different prices, right? And you could say that at the 18 o'clock, the prices will be very widely fluctuations, right? Let's say for the different kind of let's say the maximum LP, the health price is more than $100, right? But the minimum is minus 50%. That is, if for this node of the transmission network, the power I send to you, I have to pay use money. So have you remember? Okay, so have you remember in the April or in the May of this year, the oil price, the international oil price is
Down.
is minus $37. Like if
This
you go to the
buy
oil,
from the store.
yeah, if you drive your car to the oil plant to repair your oil tank, he pay you the money.
Money.
Yeah.
Or 37%.
Okay.
Uh,
Okay, so we're just to finish there. So yeah, only 2 minutes. So okay, so I will just to introduce these topics to you in the next lecture. Okay, see you next Wednesday, and our homework will be issued in the Wednesday, and of course